Okay, for people joining this live stream, we are doing a review of incremental language development for Wolfram language. Some of this might still be making it into version 12.3, which is coming up. Other things will be for the future. Okay, RulePlot.
Right, so we have Mano with us to discuss this. And if we can go to the documentation page.
Yep. Do I need to update documentation, or is it fairly?
We implemented this yesterday. If you have updated since yesterday, it should be enough.
I would assume I have.
No, RulePlot.
Okay.
Okay. Yeah, so the first thing is that now there will be this new notation for underdetermined or non-deterministic Turing machines. And
right.
I saw a typo immediately. It should be Turing machine rather than Turing.
Right. So it needs to know that for a Turing machine. For a cellular automaton, by the way, we can also have underdetermined and overdetermined cases, and I don't know whether it objects to those.
I can check and
yeah. Why don't you check that? Yeah. I mean, I think the reason it needs to know for a Turing machine is because of the head. Oh no, it needs to know for a cellular automaton as well because of the color levels.
Okay. I think I can do it.
But do we need to explain here what we mean by underspecified and non-deterministic? So for example, this is something that Manu explained to me. I didn't know before.
Yes, we should. Okay.
I think my main confusion was that I would have expected S and K to be in the spec, but somehow we need some sort of embedding into a larger set.
Why does it just say Turing?
Yes, it's a typo. Right? It's a typo. It should be Turing machine.
Yeah. Oh gosh, why is it doing that? That's wrong.
Yeah, sorry, we can fix that later.
Okay. All right. Okay. The question is, why isn't it in Turing machine? It's a good question.
For Turing machine, it doesn't really matter, right? Because it just generates the result of the evolution, but S and K only matter for when you're rendering the visuals.
But we could still give it as an advisory thing in the Turing machine.
How would that work?
Well, the case, okay, so we've got NSK. What's this? Why isn't this a reasonable way to do it? Do you see? I don't know why that was futurized, right? I mean, because then it's directly analogous to NSK, where we are giving the S and K.
Right. Okay, I can make sure this case works.
I think that's what we should do rather than this case. I'm sorry to say. I think we goofed here. I think this is ugly because this requires us to be, and we can, you don't have to take this out, but I don't think we should document this. I think this is the right way to document it.
Okay.
So that rule is representing what we call here spec.
That is correct. Yes, but no, the spec, because in this case, right, we could say Turing machine (1507, 22). Okay, and that is okay. So there's a rule plot of that. Okay, now what we're proposing is that in here we be able to give the whole, blah blah blah, arrow blah blah blah, etc., 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 and then this would give the right. I think the correct thing is machine with explicit rule given. Okay, and we could say here, if the rule a particular rule if a rule has multiple specifications for a given configuration, the first one, Turing machine, will use the first one listed. Okay, so that's dealing with the okay. Where do we say that RulePlot shows the results? We say the form rule SK can be used to specify multi-way, non-deterministic, and other Turing machines in which there is not necessarily a single case in the rule for a given configuration. I think this is how we should do it. Does that seem okay to you guys?
Yep, makes sense.
Yep. So we added some examples in the RulePlot in scope section.
Okay, that's good. Let's see, but I think these should be changed to the new form.
Right. I think, for example, if you look at Turing machine at the end of system evolution, Turing machine, or there too, at the very end. Yeah, so those cases are non-deterministic and under-specified.
Okay, I think it'd be useful to give.
So evolutions are in the other section further down. Turing machine.
Okay. The underspecified one will work fine. The overspecified one will just pick the first one, right? I know.
Yeah, it'll just depend on the order of the rules.
Yeah. Okay, I think this is good. And yeah, and okay, we can unfuturize this. How do we do this? 12.3. Okay. Explicit rule somewhere we should document the fact that for a Turing machine, what we should say here, in the Turing machine case, can be used to specify a Turing machine in which that is assumed to have S states, in which not every there's not a single case, oh gosh, in which let me see, specify Turing machine
in which the behavior is not uniquely given for all SK configurations.
Okay, in which rule does not uniquely specify transformation for all 2SK cases for each.
Is it 2SK or SK?
It's SK. Thank you. I think that's right. But which nevertheless will be rendered, but which nevertheless okay. Okay. By the way, I don't know whether plot theme has been developed any further for this. What's this picture? Let's see.
Yeah, that's the second point. Where to put that illustration?
Ethan on the live stream is commenting that little arrows in the Turing machine cells are not centered. Centroid should be pinned. Why are we saying that? This little circle, it's like a dial. I don't think that's wrong. Do we need this picture?
Perhaps not. I don't know. It was there, and we just wanted to know whether.
I'm not. I have no particular. I mean, I think it's like you see it, you do it. That's what we need to have happen. This is an unbelievably complicated Turing machine. Let's skip that and put it lower down or something, because we need to get to these non-deterministic ones, because that's far from obvious. And I don't even understand how this one works. This is assuming you've got to be able to say,
I think we have an evolution for that one in the next section. So perhaps that's
Okay.
clearer.
okay, all right, this seems reasonable. Okay, let's move on.
Yes, so the second point you already addressed, and the third was just
Single state cases. Yes, I think a dot. I
the
think that's
dot,
what
just the dot.
I think so. I think that's what I did in the multi-way Turing machine document.
We went back and forth a bit, but I can make the dot happen.
What did I do in the end? Didn't I do a dot in the end?
You used a dot in, I think, like one case, but for most of them, it was the teardrop.
Humph. Should we be able to select between those? Well, I guess you can by just saying it's a two-state Turing machine.
Yeah.
Yeah, so we might want to make some comment that the one state, I mean, we do it and then we'll make a comment later that the one state case does that.
Okay.
One day we should probably have some plot themes for even cellular automata. I don't know whether we have those for different color schemes and so on. Do we have those? Not clear. Well, take a look, Mano.
Okay. I will.
Okay.
Okay, so I think that we don't need Mano anymore.
Okay.
If
I mean, okay. Great. Okay.
Thank
Thanks, Mano.
Thank you. Bye.
Bye.
Okay, so this is a question that has appeared while working on lexicographic order on associations. And so
Well, let me just do the update so I don't forget.
Yep.
Okay, lexicographic order and associations.
Yes, so the first thing I should say here is that there are two different questions here, and the important one is the second one. So one question is order inside one association. And the other question is how to order a list of associations. So what we are interested today is the second question. Right?
So this key sort.
Right. So this is order for one association. I just wanted to say that for one association, we can sort by values or by keys. For example, here we have translations from Spanish to English. So we can say sort the values using English or sort the keys using Spanish. So that's great.
Right. Mm-hmm.
But we don't have a way of sorting by both at the same time, which is the question that's going to appear now. So when we have a list of associations, in general, in the system, canonical order is short lex. The first thing it looks is length. But for associations, it's lexicographic. So it's sorting by looking at keys and then values.
Not using the length thing.
Not using the length. So for example, you see how in this first order, even though the first one is longer than the second one, it still prefers the first one because the first
Why
key.
did we do that?
So after thinking about this, I think this is good, for example, for data set, lists of associations, because then things get sorted by their keys. It feels natural there.
Mm-hmm.
So this might have been, but the truth is that I hadn't realized this after so many years. This has been implemented since 2014. So I don't think this is something we should change lightly.
Mm-hmm.
But now that we know that order itself is lexicographic, somehow lexicographic order feels as if it should follow what order does already, because it's already lexicographic.
Okay, so what's the question here?
Yeah, so the question is that last week we had said, okay, let's lexicographic order sort by values. But what we see is order is lexicographic by keys. So what I'm suggesting now is that we follow the same thing, so that order and lexicographic order are consistent.
Well, another way to put it would be, why would we have that happen? Because then lexicographic order isn't doing anything different from order. In other words, we might as well have both functionalities available.
I see what you mean.
So we ignore keys and basically pretend it's positional?
I think that would be the best thing to do, because given that order is doing lexicographic by keys, that functionality is already available.
Mm-hmm.
I think in terms of what we pass to P here, I have to believe it's this.
Well, if we decide to go by values, we would be passing just 3 and 2, and because we wouldn't care about.
I see.
In fact, the problem is that because order is passing both internally, effectively, the question is, if we wanted to generalize that case, we would have to pass these pairs, which is a non-standard thing to do.
Mm-hmm.
But if we go for values only, then the problem is solved.
Then I think that's what we should do.
Okay.
I think lexicographic order then should be applied to values, which is kind of the central dogma of associations anyway.
Right. That was the argument last week before we had realized this difference.
Right. I think that's okay. I think we should document the difference, but I think it's okay.
Okay. Any comment, Danny?
No, I think, so basically when we have two associations, we extract their values and work from there, is what it sounds like.
Exactly. You were thinking of using normal to extract the key value pairs. It would be just not extracting values.
Okay. There's still the issue of, if I remember correctly, there was just an outrageous problem with order involved with associations. And
I think that was a small bug for Konstantin to consider in order of associations.
okay, but if that's done, I assume that what I'll be doing with lexicographic order will not in any way interfere with that.
No, I don't think so. It's just that you have to use values.
Yeah. Okay. Fine.
Okay.
Okay.
Yeah. Okay. Well, that's all. That was quicker than I thought. So we reviewed these ones last week.
Okay.
So,
all right. So let's go on with the ones we haven't reviewed.
Exactly. Yep. And we have Rick with us to discuss this today.
Toggle button. What is this? Okay, what is this doing?
I guess every time that you click, it does the next. Some sort of cyclic.
Per the comment, it's not something we're suggesting as its own function. It's something that might be considered as part of button or toggler.
If I can understand what it does.
I think it was most similar to toggler, which we already have, and that could possibly be extended to support this.
I think we should ask somebody like Lou what they think, because I'm not. Why did you write this? And if so, what was it useful for?
That was Michael Salami.
Okay. I have to admit that my use of toggler is hardly large. Okay, so toggler, I see, it's just doing values, but here, this is taking an action. I think we should ask Lou. I think it's fine.
The fourth usage on toggler is similar. I think the main benefit of this over toggler is it delays the evaluation for when you click.
Yes.
Which I don't think toggler can do that.
Right, and I think button does stuff like that.
Yeah.
Okay, so this gets shipped to Lou as a question.
I think so. I mean, to me, this is more of a button story. And, the fact that button doesn't take its functionality. I mean, the fact that button has a label and an action like that. This is like a multi-button that has a list of delayed rules to create its actions. If that makes sense. So that's the key thing, it seems to me, here. Okay, I'm going to let you discuss that. We have an interrupt from Sander here asking that we look at variance around and other such things. The question is there a way to get all, I mean, in other words, if these numbers could be turned into around numbers, then we could have every function work on this, couldn't we? Or am I wrong?
Variance around. So do around? No, do just around of that list. I'm not sure I understand what this function is doing.
What is that doing?
So this is taking the mean and estimating of deviation.
What's the difference in that and mean around?
The mean around is it. I mean, the mean is the same one, but the error is smaller. So mean around is estimating the mean and the uncertainty of the mean, not the deviation of the distribution. So it is.
You know what? I didn't know that it worked this way. I should have been using this.
So this, I mean, if you imagine that there is a Gaussian, so this is estimating the width of the Gaussian, while the second one is estimating the position of the maximum of the width of the Gaussian, sorry.
Gosh, I should have been using that first one a zillion times. Huh.
Right, so a round of a statistical distribution returns the mean and the standard deviation. So this follows the idea that a list of numbers is a discrete statistical distribution.
Right. So Sandra's commenting that this variance around returns the error of the variance. Yes. But so, I mean, my question would be, okay, so if I'm not mistaken, I mean, there's one approach would be to say empirical distribution. Let me just understand whether this is doing what I think it's doing. Okay, so there's an empirical distribution there, and then we say mean of that. Okay, that's your 1.97. Right. And if I then say standard deviation of that.
Right.
No, I'm confused.
No, that's the 0.6 of the first one.
Oh, so, I see.
Right. So that's exactly what the first one is doing. If you do, I mean, if you do input form of out 10.
I'd like to point out that we've got Rick here, and we're off on something of a tangent outside of the scope of this meeting.
Okay, we're going to continue with this tangent for a little bit. So what's your point, Jose?
I was expecting the 0.58 to be 0.53. I have to investigate why there is a difference. So some probably empirical distribution has done something that has slightly changed that number.
I see.
So my point is that in the same way that we can assign an error to the 1.97, we could also assign an error to the 0.58, which I think is what this requires. But the 0.34, that I don't understand where it's coming from.
Okay. But in general, mean around is an estimate of the mean of that thing.
Mm-hmm.
Okay. But so I could equally well estimate the kurtosis of that thing, couldn't I?
Yes. And it would probably also have an error. And the standard deviation, so imagine, for example, that this distribution takes more and more and more numbers. Then the 0.6 will stay constant in a round, but the mean around will get smaller and smaller in the second number, because it will be able to estimate that.
Right. So I understand, but so you know, what we might want is some kind of I mean, this isn't a good word, but estimate around kurtosis and then data, something like that. I don't know what it, does that make sense? I mean,
so I think what we should have, because there are some very many things we can compute, is an around value, and then we start asking for many properties.
okay, but I mean, I think what's going to be useful is, because it is a very, it's a very definite thing. We can compute the kurtosis. We don't need to get in. We need a derivative of the kurtosis, don't we, to be able to get this error? Is that not correct?
It's just a formula. I mean, all these estimators have allied formulas.
Okay, but I mean, the question is, can I put an arbitrary function in here? Or does that not work?
That I don't know.
Okay,
I mean,
why don't we think about that question, because that seems like it's the general case.
Mm-hmm.
It's a function that takes a list as an argument, and it's okay. Let's see. So Sandra's commenting that's probably an n versus n minus 1.
Right.
Yeah, that's probably why this. Sandra's saying it's not that easy because the propagation of the errors that the formulas get more and more complicated. As you get higher and higher moments, basically, of the distribution.
Right. But as long as it is a moment, I think it's computable. But general functions, that's what I don't know. Because then we enter the transform distribution general case, and that's very hard.
Yes. Well, the question is, what packaging could we give for, for other things like this? What's the right way to do packaging? Okay, it's a separate discussion, but I think this is it's a good thing to raise. Let's keep going down the list here. Non-convex hull. Well, I have to say, I've definitely used this.
I think it's a very nice function, actually.
Yeah, I think it's very useful. Somebody mean to turn the camera on? Oh, okay. How would it fit into other things that we have? Do we have somebody from computational geometry here?
No, I don't think so.
I'll say it might fit in a bit with regions, since it's a way of meshing them.
Yes. So this operation, there is something called alpha shapes, I think it's called, which computes this.
Yeah, that looks like the alpha complex. So it's a subset of the Delaunay triangulation.
Okay, but the thing that, I mean, we got to have somebody from the group that works on region stuff, because I mean, this seems like a very good function, and right now they have discretized region, but that's a different thing. I'm not sure the name here it's a little weird. Okay, so if I take those points and I say, oh great, okay, whatever, and I say convex hull mesh of that, okay, I get this. Okay, and this thing here, Sandra's saying, should non-convex hull mesh be an option to convex hull mesh? It seems a little weird to do that, because it says convex hull. It really isn't a convex hull. I mean, that is profoundly not a convex hull. This function is a function we want. So there's a question for the computational geometry team to figure out how best to do it.
It might be a meshing function, but it's definitely not something related or should be subsumed by convex hull meshing.
Yeah, I agree. It's
yeah, and this requires additional parameters to specify. I mean, this is a very clear case, but if the points are not so clearly grouped together in a clear region, then it's very difficult.
Right. So for the computational geometry team, definition data. What is this? Oh, is this a better form of question mark?
This is basically a pretty packaged version of the language backtick extended full definition.
Hey, that's not what I'm asking. I'm asking right now, if I give one of these definitions and I say question mark F, I get something, right?
Yeah.
Okay, how does this relate to that?
The question mark F is just like a display thing. This will actually package up all the definitions into a blob like that you can use later in other sessions.
So I see. So
computational, not a side effect of printing.
Okay, so what this is doing is it's packaging up down values and things like that. How do I then rehydrate them?
So I defined it as up values on it. So if you look a little bit further down, get of data will reload those definitions, including the dependencies.
So wait a minute. So this is an interesting thing. This is interesting. I mean, so this is basically a micro version of save. Is that correct? I mean, it's kind of it's an interesting idea. I mean, it's sort of like iconize. It's a version of, this is a way of essentially creating an in notebook saved object. Correct?
Yeah.
That's an interesting idea. I mean, it's an idea that's relevant. Okay, let me think about this for a second. I mean, I could also think about this as an iconized version of a bunch of definitions, but this is a nice, clean way to do it. This is a good idea. I'm not sure I like the name, but it's a good idea.
It could also be an extension to iconize. Maybe iconize could have include definitions as an option and just automatically do this stuff.
Well, yes, but iconize. Oh, by the way, Sandra is commenting on non-convex Hull mesh that it's potentially a second argument to convex Hull mesh. Conceivably, we can raise that with the computational geometry people. But okay, so you know, this is something we should have thought of before. So iconize, which is also something we should have thought of many years before we thought of it. Okay, let's run through what this really is. So iconize is a displayed thing. Let's say range of 10. Now I click that, I say iconize, and I get that. And it really is, you know, just a way of not having to see all of that stuff. Now, what you're saying your thing is doing here is, I need to remember to remove that definition, but anyway. Okay, so if I just say data of F, why is this taking so long? Okay. Huh. An F could depend on G.
Yeah, if you define G, it would say 2 symbols in there.
Okay. This is an interesting thing. Let me just think.
So what is now the relation between information of data and information of F?
I think information of F is just giving the F direct stuff, not the G. Right?
I see.
That's not giving the subdependencies. Now, presumably, information of %22. Well, okay, so it's giving a little bit more stuff. It's saying that it's got both F and G inside it. Actually, this is really interesting. I mean, so what this is allowing one to do is to have essentially a package in a notebook.
Yeah, exactly.
I think Connor should look at this in connection with the Packlet stuff. But this, and also in connection with what he's referring to as the new package format. Let me think about that for a second. Okay, so you have this. I mean, to me, it's an interesting thing to be able to, yeah. Okay, I'm still thinking for a second. This, so it's also an alternative to initialization cells. Yeah, I really like this. I mean, I think this is a really good idea. I think it needs a little bit more development. Why don't we get Connor to think about it, and maybe you can talk to Connor in the context of the new package format.
Sure, yeah, I can talk.
But it seems like a really good idea.
Although I'm not sure how it would relate to package format, because this is like, if you did input form of that definition data thing, it's like,
I'm aware. I know. But I mean, it will be, the thing is, I mean, it has no direct package stuff inside it. I just think conceptually, this is like a package packaged into a notebook, if you understand what I'm saying.
Yeah.
Because mostly, when we think about a package, see what this is, I can imagine, right, being able to take, if I take your average, why is this so slow? What's going on there? Okay, so imagine I have something from here. I can imagine wanting to take that whole notebook and say, package that package, so to speak, into one of these blobs, right? Because I want to include it. I mean, this is something we've not been able to do, but it's a very useful thing. It's like iconizing the definitions in a bunch of initialization cells or a package file. See what I'm saying?
Yeah.
So instead of having this hanging out on my file system somewhere, it's just in the notebook, but it's in the notebook in a form that isn't, that isn't particularly ugly. Right? I'm not copying. And I could imagine a version of your blob, I suppose. Yeah, that's an interesting question. Could your blob actually refer to an external? I mean, it could have something where it says, go look in this place, but if you can't find an updated version here, or if you can't find that place, go back and use these definitions that I'm using here. But this is the use case that I can imagine here, which is actually a very useful use case, which I should have thought of years ago, which is, as I say, packaging a package so you can put it in a notebook. Does that make sense?
Yeah. And for what you're saying about checking a file, that would be useful. For example, if like you didn't currently have an internet connection, and normally it would like load definitions from some remote file or something, but if it's not available, then use the bundled stuff.
Yep.
Yeah,
I think this is a winning idea. So talk to Connor a bit about it, because I think it relates to the new package format a bit. Because I can imagine something where it also relates to packlets, because you could imagine a local version of a packlet that is one of these blobs. See what I'm saying? Where the whole packlet is inside your notebook, and where perhaps it refers to the packlet, but can always fall back on what is in the notebook, so to speak.
So presumably it would take a context or perhaps a list of functions rather than just a single function.
Exactly. Yes. And I mean, this is like, I mean, in some weird sense, it's like save blob, in the same sense that import string or export string exports not to, by the way, here's another idea related to this. So we have this notion of imported objects. I wonder whether export string should be generalized to also have the notion of, I've exported it to this blob, which I can then move around and re-import if I want to. I mean, I guess that's essentially what export string and export byte array do. Export byte array is probably the closest to what I'm talking about there.
Yeah, that's why I typically use import or export byte array over string, because
right, you can just store anything, and in fact it does essentially a blob array there, because it just, the byte array is shown as a blob. I think this is a really good idea, Rick. So, I mean, can we bring this back in another one of these meetings and, talk to Connor and so on and see what you can figure out here?
yeah, I'll talk to him about it.
Took me a little while to understand what the heck this thing was. Okay, corellogram. These are famous. I mean, this is really for, I mean, this is really like spectrogram. It's in that family, isn't it? Anybody want to comment on that?
I think it is. I'm not positive.
Okay, so I mean, to me, this goes to shoddy. Seems like a reasonable thing to me. And it probably has a bunch of options, like spectrogram has a bunch of options. Make sense?
Yes.
Yep.
Well, it does, except I'm wondering if it actually goes to Gauch's group or some combination.
Possibly, yes. Somewhere between shoddy and Gauch. I don't know whether it counts as signal processing or statistics.
Okay. If you're talking geographically, that would put it in Bulgaria, I think. Sorry.
What? Never mind.
Between the countries.
Yeah, but they're both in the US, right? So
yes, they are.
Okay, that's.
I think Chicago and Champaign. So.
Yeah, right. Okay, fine.
Yeah,
so that puts it in Kankakee or something.
Kankakee, exactly. Yeah.
Okay. Hex string to real.
The author wasn't in that particular meeting.
Danny, why did you write this?
I wrote it because I did not suggest that it be promoted. I wrote it because it was requested on Wolfram Community. Somebody asked how to do this, and once I did it, I thought it would make a decent submission.
Yeah, but I mean, I'm trying to understand the more general case of this.
Well, I mean, what it is an attempt to get computer arithmetic to work correctly, round tripping between our numbers and what your standard IEEE doubles.
Well, yeah, if anybody uses hex string versions, I mean, when you write a literal in a C program in modern times, in ancient times, there used to be, I mean, by ancient, I mean 40 years ago, there used to be various ways to indicate, mantissa exponent and so on. What do you do in modern times? Can you do it this way in modern times?
As a hex string?
Yeah.
I think I see that in C occasionally, I think. Well,
but that's the question, is right now, we have the ability to encode as hex integers, basically, right? What you're saying here, I mean, we have, base 64 encoding and things like this, right?
Yes.
So the issue is, if you have an IEEE number, how do you, how does that work with respect to those encodings?
Yeah.
I mean, I assume that Mark or somebody would know that. I think we should ask. This seems like the kind of thing we should have, but I don't understand how it should relate to things like, base encode, for example. By the way, what is this? Is this for some reason?
I don't know the answer to that. I mean,
I just want to report the bug that the bottom of this raft is missing at this magnification.
I got it.
Okay. Sorry, go ahead.
No, I was trying to make sure I got the emulation of computer arithmetic correct to the last bit to the best of my ability was the point. Whether I did or not, I don't know. And
Okay, so
No,
Mark is
wait.
a sort of world expert on this stuff. Why don't we ask him and ask whether there is a more general category of round tripping, machine numbers through hex and so on.
Would this be something to extend from digits? So that can already take a hex string, but it's just for integers.
That's a good point. Yes, the answer would be yes. Yeah, with some kind of IEEE, I could imagine something like this, from digits of this thing. I mean, if I give that as a hex string right now in from digits, I assume what will it do? Okay, I'd assume that was a hexadecimal thing, right?
Yeah, I think it's implied the second argument is 16. So maybe there could be a third argument saying like what type of number.
Well, it could be IEEE, for example, here. That makes good sense to me. Ask Mark. Makes sense to me.
Can
we move on? Yeah.
Sure.
What are you pausing about?
I never get answers when I ask questions.
I'm rolling my eyes.
What can I say? I don't expect to get an answer back when I ask.
That's depressing. Then I think Devin here is responsible for going chasing it.
Okay.
Go through my chasing infrastructure if necessary.
Yeah, okay. If it doesn't involve me, the likelihood goes up.
Wow. You sound as unpopular as I feel.
Not always that way.
Anyway.
Right.
By the way, Sandra is commenting about supporting around and fit, linear model fit, and so on. Yes, it is in progress, but it is, as you suspect, quite difficult. And it probably is going to be helped by the fact that around now uses the compiler and will be dramatically faster in version 12.3, right, Jose?
Yes. I'm hoping. I mean, the work of extending it through the statistics functionality is hard because the statistics functionality is very large.
Right.
But
that's
yes,
a Gosha project. That's not your project.
Exactly. Yeah.
Okay. Replace all unheld. I need to run off in a minute here. Look, there's a whole class. I never know what that means. I wish people would actually put their names there. And somehow things that I wrote seem to not have my name on, which is just fine. But
I think this is something in the developer context and nobody knows.
Oh, I see. It's long lost in antiquity.
This might be from general utilities.
Okay. Well, whatever. Attempt to transform that would normally be evaluated. I don't know what this is, but there's a whole class. Look, there's two categories of thing that I'm keen to look at. I want three categories. Manipulating code in held form, dealing with the tracing of the execution of code, and tracing structures and causal graphs related to tracing structures. And the third is multi-way and non-deterministic computation. And those three things are all kind of heavy lifting language design, which once 12.3 is out of the way, I think we could try and tackle a bit of. This, I think, is in that category, is in that gaggle of stuff related to held code, held code manipulation. I think we need to treat it in that collection. I'm just curious what this is, and then I really need to go. In fact, I'm supposed to be doing another live stream at the 30 minutes past the hour about a completely different topic. Always good to be at some business and innovation Q&A. Okay, what is this doing? Oh, I see. This is for another time. We need to talk about this another time. It's going to take me a moment to understand what the idea is here. Well, Well, there's a lot of good functions in here. This is great. What fraction, just to give me some sense, how many functions have you picked out from the function repository to look at here? And how does it relate to the total number that are in there?
I think what we're looking at is about a 40% of, that are making their way into this meeting, which is more than I would have wanted, but I don't know if that's good or bad, or if we should be tamping down harder or not.
Right.
I'm curious to get feedback on that.
This is also selected by dates, if I understand correctly, right?
Yeah, we're going by chronology for a number of reasons, mostly related to sanity. But I don't anticipate that the percentage will change by too much. Certainly not in any rapid way.
You mean 40% of functions in the function repository we are considering here?
Yeah, so from the month
Wow.
of February of 2019, I think we got about 40%. So how many are in this notebook total that was sent to you?
I don't know.
I think it's more than, it might be.
I mean, I can always say, let me not write the code to find out. I can do a notebook import.
So they are sorted by rank. So perhaps it's just a matter of selecting some rank here.
I see. Oh, but why don't we just use our technology? Those are subsections, right?
Looks like.
$66, roughly, minus a few.
Okay, so that's actually closer to 50% of the total. I think they were around 140.
Okay, well, I think it's going to go down because I think it got to be more specialized, I think. I'm not sure. Yeah.
I expect it will drop modestly. I don't expect much unless we.
All right. Well, look, the things we're seeing here are worth seeing, so we should be happy.
Okay.
I mean, if we were going through here and we were rejecting them and saying, "Well, that's amusing, but it's too weird," then it's a different story. We're not saying that. We keep on saying this is interesting. We should try and look at it, putting it here or there.
Okay. Then we'll keep doing what we're doing with the reviews.
I think it's worthwhile. Sounds good. All right. Well, thanks a lot, guys. To be continued next time. Thanks to folks on live stream too.